Hello, welcome to the second week of our course on dynamical models in biology. This is module 1. In last few modules, we have discussed about analytical method and numerical method of solving ordinary differential equation based models. In this module and the subsequent one, we will discuss about different softwares or tools available to you for solving ordinary differential based model using numerical methods. Particularly, I will focus on one freely available software called JSim that you can use to solve ordinary differential equation based models. So let us look into different options that you have at hand to simulate ordinary differential equation based model using some programming language or by using some ready-made software. There are many programming languages starting from Fortran, C, Python that you can use depending upon your experience and ease to write your own code to solve a ordinary differential equation based model. Even you can use higher level languages like MATLAB for that. Most of these languages has inbuilt library function for solving ODE numerically, and different algorithms are available. If you are not comfortable with using in writing a program for yourself, you can look for ready-made software which are plug and play, and you can use them to solve your model. Now, these softwares are actually GUI based. They have a graphic user interface which helps you to analyze the model with ease. Some of these GUI can have an option where you can simply write down the equation and ask the system to simulate the model. In some cases, you have to use a particular markup language that is understood by the software to define the model. Depending upon your choice, you will use one of them. For example, software like Copasi, this is a software where you can define a reaction just like A plus B reacting to give rise to C, like this. Whereas JSim that we will learn, we will have to define the model using a specific manner, using a specific language that JSim will understand. Now, all of this software has certain advantages. Most of them has multiple algorithms available with them so that you can choose one of the algorithm based on your utility. They not only allow you to solve the ODE, but they also have certain other tools, for example, parameter estimation, parameter sensitivity analysis. We will not discuss those, but those tools are many a time very useful. And the last importance of a GUI-based simulation software is that most of them has ready-made visualization or plotter with it. So once you simulate it, the graph for the dependent variable comes up automatically. So you can visualize the simulation immediately. You have not to use a separate plotter or grapher tool for plotting your data. With this, let us start and look into the different aspects of JSim, a Java-based simulation software that we will use for our work. JSim is freely available. You can download from web. The address I have given here, www.physium.org JSim. As I have said, JSim is a GUI-based software, but it requires you to write down the model in its own language. So this language is called mathematical modeling language. Interestingly, JSim can handle ordinary differential equation, it can handle partial differential equation, and even it can handle model with discrete event. It has graphical user interface where you can plot data and your result. It has option to export your data as text file so that you can plot the graphs in some other software like Microsoft Excel. It can import SBML model. SBML stands for System Biology Markup Language. As you know, dynamical models are very common in systems biology. And different people use different language and different software to simulate this model. That's why scientists are trying to develop a common markup language that will be used by everybody working in the field of systems biology. Systems biology markup language is one such effort, one such markup language. And interestingly, JSim can export import its model in SBML format. You can also connect JSim with MATLAB. That's very powerful option you have. And the best part of JSim is that at its website, you have very well documented tutorials. You have videos, you have text tutorials, you have large number of models available there through which you can learn. So learning JSim is much easier. The first thing you should do is go to JSim website and download it. You have a link here to download JSim. When you click, you go to the download page. In download page, you have options for choosing right JSim. For example, if you are using a Windows system, use Windows binary distribution. If you are using a Linux machine, you download the Linux one. Once you are there, you have to fill up this form, which is very brief. Put your name, email, and institution name, and then download it from this click. You can download the beta version, but to begin with, I'll recommend not to download the beta version, but use the current public release. Once you have downloaded it, you are ready to go and simulate some model. Let us try some video which I have recorded and to show how you can use JSim. I have downloaded the Windows version. It is a zip file. I have to unzip and uncompress it. So let us extract it here. The files will be extracted on my desktop. Wait for a few seconds. Okay, extraction is over. I want to put all these files in a particular folder. Let us name is JSim and put all these extracted files in this folder. You can keep this folder in some other directory, for example, in program directory. Go to this folder now. Once you open, you can see other subfolders are there. We are interested in this Win32 folder. In that you have again 4 folders. Open the bin. Now in this bin you have lots of Windows batch files. We are interested in running the JSim batch file. So we will make a shortcut of that to desktop so that every time I click on the shortcut, JSim will start. Close this window. Here you have the shortcut for JSim on your desktop now. It's very easy to use. You double click on it and JSim will start. So we have got the JSim. This is a GUI of JSim. You can see it has 2 parts, left hand side and right hand side. On left hand side you have options and tools for writing the program and running it. On the right hand side you have the output, either message or the data in plot format. In the file tool, if you click, you have the options for opening a project. Remember in JSim, every work is stored as a project. Inside a project, you can have multiple models. You can open an old existing project, you can create a new project. Edit tools gives you cut copy options. Add tools gives you option to import model. As I said, you can import a SBML model. You can use that. You can create a new model as the option is given. You can add a new data set. You can add a new plot page and all these things. SBW is System Biology Workbench. That's an independent tool. You can connect to it using this option. And you have other preferences and others. So let us open a existing project that I already have made. It is in my desktop. So I open it. It is a project to model spread of infectious disease as we have dealt earlier. Remember, all project files have a .proj extension. So here I have opened that. Notice a new tab has come. And this new tab is actually the model. As it is shown here, infection underscore kinetic model is the model which simulates the kinetics of spread of infection. So you click on that tab, you will get that model. Now see, below you have multiple tabs, tabs for source, runtime and others. Source is the tab where you have the code for this model. Runtime is the tab through which you run the model, and you have others like sensitivity, optimizer and other else. Let's see the source. This is the code for the model of spread of infectious disease. I will discuss how to write this code later on. Let us just look into it. You may recognize one equation, that r into 1 minus x into x, that is there, which represent spread of infection. So this is the ordinary differential equation written in JSim code to model the spread of infectious disease. In this page, you have multiple options like file. I can print this code by print text option. So you can print it. We will not do it here. You have edit option by which you can copy, paste the code. You can find the code block. And notice there is a button compile. Once you have written down the code, you have to compile it so that JSim can run it. Once you compile successfully, this runtime tab get activated and you reach this runtime tab. And you can see the message window. It is written that job compile model infection kinetics in progress terminated normally. That means JSim has successfully compiled the program. In the runtime tab, you have multiple information. Each of these values are values of variables which I can change. For example, t mean is 0. There is a minimum time up, and this is coming from the code block here, t mean equal to 0. So either you change in the code or you go to the runtime window and change these values. I can change the value of Tmax. Tmax I have set as 20, I can change it. I can change the value of R, X initial, there is the initial value of X, all these things I can change. Either in the source code or in the runtime window. So I have changed that. Now I have saved it. I will go back and compile again. Now look, I have to change from parameter set, revert to model default, so that the value changed in the code get executed. So in model input, R has changed from 0.5 to 0.6. Now we want to run and see the output in the plot page. In the plot page, you select the model. We have only one model. You select a variable, that is the X is the only variable, so you selected it. Now this is the horizontal axis is time, vertical axis is for the dependent variable X. Let's run it, clicking run. You got the result. You can see the typical sigmoidal curve. Change the name of the axis. Vertical axis is X, horizontal axis is time t. So now we have the data. I can now change the total time of simulation from 20 to 100. Now run again. Notice the horizontal axis, it has changed up to 100. Now let us change the model input R, the rate constant, to 0.1. Run again. You see the pattern of change of X with respect to time has changed. Apart from these visualization, JSim also give you the data in text format as shown in this tab. It is a separate tab named as text. Interestingly, I can save this data as a text file so that that text file can be opened in another software and analyzed. So go to File. There you have an option of Export Data File. JSim allows you to export data in different format from comma separated to tab delimited. I will save this data in C data format, give a name, and then put the extension. Don't forget to put the extension in the file name. I will use C data as extension. So name of my file is data_infection.cdata. Save it. Once you saved, the data has got as a text file. Let us see that. Here I have the text file. I can open it in a notepad or WordPad. I can simply select the all data and copy and paste it into some other software like Microsoft Excel. Let's open a Microsoft Excel page. Paste it here. So now I have exported the data and I have it in a Microsoft Excel. So I can use the graphing tool of Microsoft Excel to draw the graph here and do all the manipulation and formatting which are not possible in JSim. For example, if you want to change the font size, color, and put some background color or put some background text, JSim will not allow you to do that. You can do that here in Microsoft Excel. So here we go. We have the same graph. So we have the graph here, and that is depending this data is depending upon specific value of the input parameter. We can put if we have a model with multiple parameter, we can draw them here also by choosing multiple curve. For example, suppose I want to plot 1 minus x. So I have created a new curve and defined it as 1 minus x and put the color blue in that. If I want to remove it, I can simply uncheck the show option. I can go to 1 and uncheck that, so x will disappear. So in this way, multiple variables you can show and check, uncheck, change their color depending upon your utility. So as you show in the graph, your data will be shown in the text format also. You can also export that data. I'll save it as a second file, and remember the extension was C data. Now in this model we have used r equal to 0.1. We can revert back to the model default, the default value of the parameters. It will become 0.6 because in the code I have written that as 0.6. Let us run once again. Now let us change the initial value of x, run it again. So you see how the graph has changed. So x is now starting from 0.1 and you have corresponding 1 minus x plot also. Let us go back again to the original value of 0.02. We have removed 1 and we will only show now the main variable x. I have run with default values. And I want to see now how, if a parameter is changed, how the data will change. So there is a loop tab which allow you to check the effect of different value of parameter on your result. So let us choose one parameter from this pull down. You have the parameter r. Let me choose that. Let us fix the start value of r. That is the first value of r that will be used. So it is by default now 0.6 because that is the value in the code. Let me put it as 0.05. and then in other value for we put as 0.1, 0.5. So I have three values 0.05, 0.1 and 0.5. I want to run this loop and see how the data changes with change in value of R. So in the all run option, you have loops run. Click on that. So in the graph, you can see multiple plots showing the effect of R on the behavior of X. The lowest one, the dark black one, is for 0.05, and the upper one, the dotted one, is for R equal to 1. Everything else is in between. So in this way, you can choose a parameter, set different values of the parameter, and use loop run to see how that parameter affects your behavior of the dependent variable. You can also see the data as text file, and you can, as usual, export that text data in a text file so that you can manipulate and plot in some other software. Here I am saving it as a data infection loop.c data, so that data I can use somewhere else. So in gist, the key points that we have discussed in this module is that there are many softwares and many programming languages that you can use to model and simulate your ODE-based model. You have to choose them depending upon your capabilities and your ease of work. If you are creating a very large model, then writing down your own program may not be a good idea. Maybe some software which can handle large model be useful for you. There are many ready-made software like Copasi, JSim, which you can use depending upon your utility. These tools not only allow you to simulate a ODE, but also allow some other analysis like parameter sensitivity, parameter estimation. These softwares also allow you to visualize the data and save the data as a text in text format, which you can export and use in some other software. In our course, I will advise you to use JSim for simulating ODE-based models, and we will discuss in another video how to create JSim model using JSim's math model language. Thank you for watching. See you in the next module.